Today we're going to talk about the Pythagorean Theorem and radicals. You've dealt with the Pythagorean Theorem before last year, but now we're going to start introducing radicals as part of the answers. So let's jump into a quick reminder. What is the Pythagorean Theorem? Well, hopefully you remember this equation. A squared plus b squared equals c squared. And hopefully, if we're lucky, you remember that it has something to do with a triangle. Now, as we look at this, we need to think about the fact that what it means. That the sum of the squares of the two legs of a triangle, in this case A and B, is equal to the square of the third side, or hypotenuse, which is C. It's the longest side. Now, the beauty of this is that there are really only three things you need to be able to do to apply this formula. Number one, the triangle must be a right triangle. That is, a right triangle means that it has a single 90-degree angle somewhere in the triangle. In this case, it's denoted by this little symbol. The second thing we have to be able to know is that we're going to identify C. And there are two ways to do that. Number one, C is always the longest side, as well as C is always opposite the right angle. So if our right angle is here in the lower right on this triangle, it means the opposite side must be C. This is really important later on when we're not given which sides are A, B, and C. We're just given a series of numbers and we need to figure it out for ourselves. So just remember that C is opposite the right angle and it's also the longest. The final thing is that we have to solve and simplify. After all, it's just an equation. We plug in our numbers and we're going to work it out. Now remember, we are going to end up with radicals in most of our answers. Let's look at an example. So let's start by examining a pretty basic triangle, what we can use the Pythagorean Theorem for. So here's a triangle where we don't know if our artist is any good. As I said before, I'm a horrible artist. I can't draw a good triangle to save my life. But here's a triangle that has sides of 3, 4, and 5. But you'll notice we can't tell if there's a 90-degree angle. Where is it? We don't really know. Each of these, they don't really look like 90 degrees at all. And, well, we're not going to mess with, protractors or anything. The question we have to ask, is there an angle in this triangle that is 90 degrees? And just based on the art, we don't know. To figure that out, we're going to apply that Pythagorean theorem. A squared plus b squared is c squared. So let's identify A, B, and C. Based on our rules, C has to be opposite the 90-degree angle or is the longest side. Since we don't know where the angle is, we'll go with the fact that C has to be the longest side, which is 5. So that's C. When it comes to determining A and B, it doesn't really matter. We can decide that, well, A is 3 and B is 4, or we could flip them around and say B is 3 and A is 4. It doesn't matter in the real problem. So let's put it all together, and we get 3 squared plus 4 squared equals 5 squared. And as we do this, we just need to solve and simplify. So 9 plus 16 equals 25. So 25 is equal to 25. That seems true, right? That's correct. But what does that mean? Because it's true, what it means is that there is, in fact, a 90-degree angle. Okay, that's the beauty. If this equation works out according to a triangle, there has to be a right angle. Where is it? Well, we know that C has to be the longest side, and it's also opposite the right angle. That means since our longest side is 5, the opposite side, or opposite angle, is our right angle. Let's take another example. This triangle that says our sides are, well, 3, 4, and, 8. We can apply the same process to determine whether or not there is a 90-degree angle somewhere in this triangle. In this case, we get 3 squared plus 4 squared equals 8 squared, which means that we end up with 25 equals 64. Well, that doesn't work, right? That's not true. 25 is not equal to 64. So as a result, we know that there is not a right angle or a 90-degree angle anywhere in that triangle. It's not valid. So this is a quick and easy way to determine whether or not a triangle has a 90-degree angle. One of the neat little things is that any set of numbers that does produce a right angle or a 90-degree angle has a special name, and that name is a Pythagorean triple. Okay? And Pythagorean triples are any sets of three numbers that satisfy a squared plus b squared equals c squared. 3, 4, 5 is a Pythagorean triple. Next, let's look at finding a missing value. In this case, we're going to look for c. Here's our triangle. Draw my little right angle 90 degrees in there. And we're going to find missing sides. So we'll say my sides are going to be 6, 8, and my unknown side will be my longest side, my C side, the side opposite my 90-degree angle. So I'll just go ahead and label this side up here as C, my hypotenuse or longest side. So building my equation of a squared, b squared, and c squared, we get 6 squared plus 8 squared equals c squared. Well, simplify. 36 plus 64 will still be equal to c squared, and we add those together until we get 100. So 100 equals c squared. Now, we don't care what c squared is. We care about c. So what we're going to have to do is get rid of this squared. But what's the opposite of squaring? Hopefully you remember from our previous discussion about radicals that the opposite of squaring is square rooting. So we're going to take the square root of both sides. As we work this out, square root of 100 is equal to 10, and the square root of c squared is equal to c. So our final side is 10. We can redraw it and say, well, we have 6 and 8, but our missing side was 10. So 6, 8, 10 is a Pythagorean triple. You'll notice it's double that old 3, 4, 5. Next up, let's look at a different triangle, something a little different. We have our 90-degree angle at the bottom, and now we have a couple of different sides. Let's say we have 2 on the left and we have 6 on the bottom. So those are our A and our B. And our unknown side is once again the longest side, our C value. So pull in our equation and start filling it in. 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. Therefore 40 equals c squared. Once again, from our last example, we know we have to square root both sides. So the square root of 40 is equal to the square root of c squared. And now we have to continue simplifying. So c is equal to the square root of 40. But 40 can be simplified further. And that's the beauty of radicals. We can get these without decimals. So let's break square root of 40 apart into a product. In fact, it can be broken into the square root of 4, which is our perfect square, times the square root of 10. And that will be equal to c. Square root of 4 is 2, and the square root of 10 can't be further simplified. So our final answer will be 2 times the square root of 10. And we could draw that into our triangle, 2, 6, and then 2 square root 10. This is going to seem silly right now that we're working with radicals instead of decimals, but it'll make a lot more sense when you get into geometry and algebra 2, where radicals rule the day when it comes to special right triangles. Last up, let's look at one more example. Once again, triangle, 90-degree angles in there, A, B, and C are around. But now, we don't know what C is. We are going to know A, we might know C, but we're not going to know the missing side B. So we'll say A is 8, our C side will be, let's say 50. And our unknown will be this last side. We'll call it A, just to make it simple. So bring in our equation once more, and we get a squared plus b squared is c squared. So a squared plus 8 squared equals 50 squared. Big number, but that's okay. Keep simplifying. You get a squared plus 64 equals 2,500. And now we have to simplify. So we'll solve by subtracting 64 from both sides. So we'll get a squared is equal to 2,436, right? Yeah, 2,436. So now we have to square root both sides. The square root of a squared will be a, and if you work it out, you'll end up with the value of 2 times the square root of 609. And that's if you spend the time. I'm not worried if you do right now. The whole point is that it's okay to have these radicals. We can find values for a or b or even c simply by solving this one equation. So make sure you're comfortable finding any missing side of one of these special right triangles.